All right, so do you see what to do here?
No.
Okay. All right. So here's my suggestion. So remember, this B thing is just a bit of notation here. And what the notation is saying is that whatever value function you give it, you can replace this whole thing with a value function defined like this.
Right.
All right. And so imagine what happens if you actually plug all that in. If you actually take this BQ star and replace it with the definition according to this operator definition above.
That says that Q star is actually equal to, well, that's the definition of Q star.
Ah, do we have a name for that?
Q star?
Sure, we have a name for Q star, but the equation that defines Q star.
Well, it's the Bellman equation.
Yay!
Oh, that was easy. Okay.
Woohoo! And you don't have to put the exclamation mark to get full credit for that one.
Oh, I don't know. I think you should require they put the exclamation mark or they don't get full credit.
No, I think it's okay.
All
In
right.
fact, anything that has Bellman in it should be fine.
Anything that has Bellman in it?
Yeah, like the Bellman identity, or the I don't know. I was trying to think of other sequels that have
The Bellman ultimatum?
yes, Bellman Reloaded. All right, so good. So with that kind of thought process in mind, can you do the next one? So we have some Q function. We apply the Bellman operator to it, and we get some new Q function.
Bellman update?
Yeah, it is a Bellman update. But this now you can think of as an algorithm. It's going to actually generate a whole sequence of value functions, one from the next.
TD?
No.
No. Well, then I don't know because I'm trying to. Oh, wait. This is value iteration.
Woo!
Yeah, I think I need extra exclamation marks for that. That makes perfect sense.
Yeah, so value iteration is this big algorithm, and it probably takes a page of code or whatever to write. But in this operator notation, boom, it's like you start off, probably to be more precise, you want to say something like Q0 equals the 0 value function or something like that. You need to initialize the value function, but then after that, you're just generating value functions from other value functions. That's exactly how value iteration works.
Yeah. And it would work even if Q0 weren't initialized to 0.
That's true. Yeah, but if we wanted it to be a complete algorithm, we'd have to sort of say where it starts and then how we generate new things from old things.
Mm-hmm. Well, it just starts with whatever happened to be in memory at the time.
I see. Yeah, that could run you into trouble, but probably shouldn't, as long as the types are correct.
Yeah. Well, it doesn't matter. They're just bits. They're ones and zeros.
Yeah, but they better be interpreted as floating point numbers, because if you interpret them as like imaginary numbers or something like that, it could make the Bellman equation act strangely.
It doesn't matter. The operators will do the right thing. They'll just interpret them as floating point numbers or doubles.
Perfect. Okay, well then we're all happy. So I guess what I was hoping to do with this example is, convince you to develop an appreciation for this particular notation, this Bellman operator notation, because we can write stuff that we care about really, really succinctly.
Yeah. Yeah. Okay. I buy that. And it means that you'll be able to fit everything in on a slide.
Which should be good. And look at how less I'm messing around with subscripts. It's very nice.
I don't know. I like your subscripts.